Ross Reels was originally founded in 1973 in Etna, California by Ross Hauk. Ross was a mold manufacturer or investment casting mold manufacturer and had a passion for fly fishing and felt that he could do, at that time, do a machined fly reel that would be mass producible, that would be better quality than anything else available on the market. So he started with the original R series reels in 1973, added the S series, which was a saltwater series of reels a few years later. The company then moved to Montrose, Colorado in 1984, and that was the same year that the Gunnison series was originally introduced, and that was one of our longest running, really kind of one of our flagship models for the company. The company's been here in Montrose again since 1984. We are, according to an industry survey that was done, we are the largest machined fly reel manufacturer in the industry. We're also the #1 selling machined fly reel company in our industry. We continue to, our company philosophy is to manufacture the highest quality machined products at the most affordable price that we can present those products to the marketplace at. We've also added a Ross Worldwide division. Everything that we do here in Montrose is machined, anodized products, and there's really our upper product line. We've added a separate division called Ross Worldwide, which addresses some of the price points that we're not able to manufacture domestically and bring to the marketplace. So we do all the design and engineering of those products in-house, all of our quality control in-house, and then those are produced overseas for us. And those hit price points in the sub-$100 retail category, where everything that we produce here in Montrose, our starting price point reel at the Cimarron is about at $150, all the way up to $600 in our Momentum series. Our products have been, our fly reels have been awarded more industry awards than any other fly reel manufacturer in our industry. Certainly is a tribute, I think, to our design team and the things that they do in terms of bringing really new concepts and new materials to fly reel design with what we do in our USA products. Basically, each reel and frame starts from a solid piece of bar stock aluminum, and we work with a multitude of different diameters of bar stock, just depending upon what series of reel and what size we're doing. So each frame and each spool comes from one solid piece. What we do in the first machining operation in a frame would be taking that solid piece and basically hogging out the center of it, creating the two legs on the frame, one being the leg where we attach the reel foot on the finished product, and then the second one being the stripper leg or the stripping post on there, which is the line guard when you're pulling line off of the reel. And then we do a little bit of the detail work internally on that, and that's all in one machining operation. On the back side of this, we still have that rough sawn cut. Then we go into another operation on another machine where we clean up the back side of that to where it looks more like a finished frame like you'd see it on the countertop in a retail store. Once we're done with all the machining, then we go through our handwork department where we do some deburring and some surface finish work on this to get it ready to anodize, and then we do ship it out for our anodize. That's really the only part of the process that we don't do internally. So this would be that frame op that we just took a look at, where it still has the rough cut back on it. We come over onto one of the other machines on a lathe operation, and we clean up the back side of that to give you more of what's a finished frame. This happens to be our Rhythm product. So from this point now it's ready. We'll go to our handwork area. We do a tumbling or a vibratory process, and then we do some hand deburring on this, and then it's shipped out for anodize at that point. So this is basically a finished machine frame at this point. Now again, we'll do handwork and then anodize, and then we'll go into our assembly area with it. This would be a spool for one of our Evolution series reels, and this is after the final machining process where we've come in and we've done all the lightning hole pattern on the face and on the back side, done some of the detailed work on where some of our drag componentry is going to be assembled into that. So again, this would be a finished Evolution spool from the machining standpoint. Now this is ready to go into handwork, go through the same vibratory process that we put the frames through, and then do some of the hand manual deburring of specific features that won't tumble out when we do that vibratory process. What it's doing right now is it's coming in and doing the holes in the arbor or the hub of the reel. which just helps reduce some weight. It adds cosmetics, but it also aids in the backing drying out in the line, just because you do have some ventilation coming from the inside of the spool. This would be a first machining op on one of our spools. This is the Evolution spools. Again, we start with that same piece of solid bar stock aluminum. The first machining operation machines the palming rim and some of the features on the face of the spool. Once we're done with this, it'll stay on the same machine, and we'll hold it by the palming rim of the spool. And we come in and remove all the material down to create the arbor or the hub, and we create the flange or the backside of the spool. From this point, we'll go on to one of the vertical mills, and we'll do all the lightning holes where we come in and drill all the small holes in the face and the flange of the spool, as well as on the arbor on the inside to create the cosmetics and also reduce the weight of the spool to where you'd see on the finished product. Yeah, this would be all post tumbling or vibratory process, so you can see how the aluminum changes much smoother, and it softens all the edges, removes all the burrs. Some of the features, like this is a CLA frame, we need to protect the threading on this particular feature of the frame, so we've got a cover that screws onto that before we do the vibratory process, so we don't lose our tolerance there. On some of the other products where we have a spindle going through the center of the frame, we need to maintain the tolerance on that spindle hole, so we'll plug that with a little rubber stopper again. So the vibratory medium, it's a hard plastic that we use that has a real mild abrasive quality to it, and we just want to make sure that it doesn't auger out or change that dimension.
This is the coordinate measure machine, and what this will do is this will automatically go around and set up origins on the part. It will numerically level this part, pick up a center of origin, a radial origin, and then it'll go around and check all the other features in relation to what it just set it up to. It's going to take 4 points here, and then it will set the part as level. Now it's going to pick up this post here as a radial orientation. Pick up the center hole as a center orientation. And now it's going to go check all these different features in relation to what it just set the part up for. And we have 5 different styluses on this, so we can kind of approach things from just about any angle that we need to. And it'll check this part in just under a minute. Whereas if we were going back the way we used to check these by hand, it would take probably a 45-minute operation.